All right, so we're going to be finding the critical points for a problem now using D&E. So here's our function, and so first thing we want to do is rewrite it. And then now you can see that we are using product rule. So we're going to take our first function, which is x to the 2/3, and we're multiplying it by x minus 2 squared. So we'll do this one first, 2x minus 2 to the 1. And the other one is 2/3 x to the negative 1/3. And then we apply product rule. So 2/3 x to the negative 1/3, x minus 2 squared, minus 2 x to the 2/3, x minus 2. And so if you remember with these, we're going to be factoring them out. So whatever you took as a derivative, that would be our smallest one. So that one is the one that's coming out. So same with the other one. This was our derivative, so we're taking that out as well. So let's start there. So we're going to take out the x to the negative 1/3 and the x minus 2. And so we'll talk about the 2/3 and the 2 after we finish this part. So if I take out the x minus x to the negative 1/3, it's gone, and I'm taking out one of these. Remember, these are always one less. So all you're really doing is throwing the exponent away for those. So this would become x minus 2 plus, that's a plus, and then x. So we just throw those exponents away, because again, the difference from here to here is 1, and the difference from here to here is 1. Now let's deal with the numbers. So we have to get rid of that third as well. We want the fractions out of these problems. So that would make this one a 6, and this is a 2. So that 1/3 times 2 is 2/3, and 1/3 of 6 is 2. So remember, whatever third you take out, you just multiply that reciprocal to that number. So if I took out a 1/4, I'd multiply by 4. But everything checks. So now we can take and rewrite this problem into something that's nicer. So f prime of x equals, and we get x minus 2, and then inside that bracket it becomes 2x plus 6x, which is 8x minus 4, all over 3x to the 1/3. And that's why we wanted to factor it out, so that we can get that denominator, which gives us our D&E. Now you can factor out the 8 as well, or the 4 as well, to make it a little bit nicer, but we're just going for these right now as this. That is our D&E, and that is our 0. So the top numbers would be 0, and if you take 4 and divide it by 8, you get a half. And then the bottom number that makes it 0 would be 0. So no matter what exponent it is, this is only going to become 0 when x is 0. So those are our 3 critical numbers. And now we're just going to test them with the calculator. So if I take my calculator and I input that function in, I now want to adjust my window. So you can see I'm between, that's a 2. I know where I got the 0. 2, half, and 0. I think I was thinking of that one. We're going to be between 0 and 2 for our stuff that happens. So we want a little bit less than 0 and a little bit more than 2, and then hit zoom 0, and it should give us the graph that we want if we did everything correct. If we didn't, then we go back and we find our error in here. So like if you multiplied this incorrectly, that number wouldn't have matched and it wouldn't have worked. So you can see right there is 0, perfect, 1/2, and 2. And so when we do our traces, if that's a critical number and a critical number, it shouldn't show up when we do it. So trace 0, yeah, see, it's off the graph. If you want it to show up, you got to go to window. We need to take this down a little bit, so like -4, hit graph, and then we have to wait for it to graph again. But that's our 0, and you can see the other one is hitting right at 2, which is perfect. So trace 0 is 0, perfect. Trace 2 is also 0, there's our min, and then trace 1/2, or 0.5, right there. So those are our maxes and mins. So that was 0, and that's 1.4174. So now we make our critical points. 1.4174. This was 2, 0, and then the D&E one was 0, 0. So you can see that's where our D&E comes into play. If you didn't factor this, you may not have noticed the 0 as being a D&E, and you can see it makes that sharp point in there, right there. So that's our D&E, it's a critical number. Now, for intervals of increase and decrease, we're going to do this nice and quick. So we plug 0 in, and then 1/2, and leave some space for some work, and then 2, and then we go to our calculator and we interpret. So it's decreasing, so we know that one's going to come out to be negative. And then it's increasing, so we know that one will come out to be positive. And then it will be decreasing and then increasing from there as well. So negative, decrease, positive, increase. So now we just have to show it algebraically as well, analytically. So we're going to plug in a number here, f prime of negative 100. That's between 0 and infinity. Something in between here, we could do a quarter. And then we can do 1, because that's in between a half. And then we can do 100. So again, when you plug these in, you only want to use the stuff that makes it positive and negative. So we're really plugging it into x minus 2, 8x minus 4. And then on the bottom, it's really just the x because there's no exponent here. If this was 2/3, that would always be positive. It's 1/3. And you can plug it into the actual derivative as well and pull these numbers. But we're going to do this quick. So if I do a negative 100 into the first one, that would come out to be negative. And if I do a negative 100 here, that would also come out to be negative. And then the bottom is definitely negative. So that turns out to be negative, and it checks. So 1/4, that would come out to be negative. That would come out to be negative. And then the bottom is positive. So that gives us our positive again, a nice little smiley face there. So again, negative, negative. So remember, 1/4 of 8 would be 2. 2 minus 4 is negative. So, and that one's positive. All right, and then the 1, that would come out to be negative, positive, and positive. And so you can see that is definitely negative. And then the last one is positive, positive, positive. Everything is positive. So it checks out perfect. So intervals of increase, that will be from 0 to 2, union 2 to infinity. And intervals of decrease would be from negative infinity to 0, union 1/2 to 2. And now we have everything that we need. Now, maxes and mins. So if you remember a maximum, we need to have increase, decrease, right? And for a minimum, it needs to be decrease, increase. So if we're doing maximum, we're looking for that positive to negative. So let's look for that. And that would be here, positive to negative. So it's at the half. And what was the y value for the half? 1.4174. So 1.4174 at x equals a half. That's our max. Any more positives to negatives? No. And you can even look at your graph. You can see it comes down. That's a minimum. That's a maximum. And that's a minimum. So we're getting 2 mins and 1 max. And so we're looking for, again, for minimum, negative to positive. So that means we would have a minimum at 0. So we have a minimum of 0 at x equals 0. And then we also have a minimum at 2, so of 0 at x equals 2, right here. So decrease, increase, minimum, decrease, increase, minimum. You can even see the shape that we're getting here, right? But it's a peak, so it's not that curve, but same idea. So now absolute min and max. So the only way it becomes an absolute max is if our graph will do this. It doesn't really care, but it goes to the top and then comes down. So we know that it's coming increasing in, decreasing down, and it is the highest point. So there is no maximum. None. You can even look at the calculator to verify that. We're coming down from negative infinity, and then we go back up to infinity. But minimum, we do have minimums of 0. That is our 0, and it occurs at x equals 0 and at x equals 2. So we do have an absolute min. You can even see our graph comes down, hits this, comes back down, and hits this. So we would have a minimum at 0 or 2, whoever is the lowest point. And there you have it, the most complicated problem that you're going to get in your homework. Thank you.